This problem is about determining whether or not a string of parentheses is valid or not. So we are given a string S and it contains three kinds of parentheses, and these are the only 6 characters that can be present in the string. So only 6 chars, 3 sets of parentheses. And we need to determine whether or not the order is correct of these parentheses. And so there are a few kinds of styles that we might encounter. So we might have a linear sequence where it's just one parenthesis set after the other. In this kind of example, like all you need to know is what the previous char is. So only previous starting parentheses needed. But if you think that because the parentheses can be nested, then it means that if you have something like this, then we need to know every starting parentheses. Um, so, for example, like if we are given this first one, then we also need to know and store this one and this one, because when we start to match the ending ones, we need to know what was the last previous one until like all of the parentheses pairs have been matched. So we kind of want to have a lookup table so that we know what the matching parentheses are. And so we can just do a dictionary of char string, and this will just contain the three kinds of parentheses we can have. So we will match up each of these brackets, and now we want to know how to actually connect all of these parentheses in a way that we can match every single like pair. And the easiest way to think about that is if you have a regular list, when you call append on a list, it adds the element at the end of the list. And then if you use the pop operation, that pops the last element. So it is behaves like a first in, first out order, which is exactly what we need in terms of a stack behavior. So when we add all of, well, we're going to stack up every single starting parentheses we see, and then as soon as we see a character that is not a starting parentheses, so it's not in the keys of the brackets dictionary, we want to find out what the last starting bracket was in the stack, and then we want to make sure that whatever char we're at equals whatever like matching um, pair in the dictionary is. So we want to store a stack, and this is going to be we can name it starting brackets stack, and this is just going to be a list of strings again, and we initialize it to an empty list. And it's starting brackets only because we only need to store what the starting brackets are, not the ending ones, as that's what we want. Every time we reach an ending bracket, we need to make sure that the last starting bracket we saw in the sequence of characters is the corresponding like matching pair. So we can do a iteration over now the string, and we want to see if char is in brackets dot keys. That means it is a starting bracket. And so that means that we need to um, add it to the bracket stack. So starting bracket stack dot append the character. And if it is not, then that means that it is a ending bracket. Because remember, like in this problem, it says that the brackets are the only characters that you can find. So we don't need to worry about having non bracket characters like regular characters. Um, if we did, then we would need to kind of explicitly store what the ending brackets are. So in this else condition, we want to get what the last starting bracket was. So last starting bracket, and this is going to just be the element we just added to the stack. So we're going to pop the last element, and that is done using starting brackets stack.pop, and this gives us the stack behavior that we are looking for. So now we want to see if the last starting bracket, what the corresponding ending bracket value should be. So expected ending bracket value, and this is going to just be a lookup in our brackets dictionary of the character or of the last starting bracket that we have. And if the character that we are at is not equal to the expected ending bracket, just shorten the variable. If it's not equal, then we know that it is not valid. So for example, if we have stored in our stack like these parentheses, for example, like this, then if we are at this character, which is this ending bracket, but then in our stack we have added the curly bracket, then it would be expecting the last starting bracket would be equal to this curly bracket, and then the expected ending bracket would be the lookup on that key, and because it does not match, then we will want to return it false as it is not valid. And before we try to pop from this starting bracket stack, you could imagine a scenario where you only have these starting brackets, or you don't have ending brackets, and so you might not actually have any starting brackets. So for example, if you only have like ending brackets, then we would kind of not be able to pop. So if not starting bracket stack, then we also want to return it to false, because this means that we have ending brackets, no extra ending brackets. And if it gets through this entire loop, that means that all of the brackets have like some pair, but if there might still be more starting brackets that we haven't found matching ending brackets for. So we can do a simple check. If we still have any starting brackets left, then that means it has failed. It's not valid because there are extra and like extra starting brackets. So starting brackets. And if there is like the starting brackets list is empty and we got through these checks, then we know that it is a valid string. Should indent this. So if you run this, then it should pass all of the test cases, and this would be the most optimal solution. There's not much else that we can really optimize here, and this is quite intuitive as well. So that's all for this problem, and thank you for watching.